baby problem, which is again a CDC, a Central Disease Control and Prevention report that 25% of big baby between the month 6 to 8 months old in the United States weigh more than 20 pounds, right? A sample of 150 baby is studied. So if you look at this thing here, if you read this question, I told you guys yesterday that if you read this thing here, this is the word, or this is the keyword that you want to identify, right? I mean, if you do the homework on chapter 6.4, you see this word in 6.4, you don't see this word in 6.2 or 6.1, right? Because again, in 6.2 and 6.1, they only ask you to find the probability, find the value, find something, right? This one here in 6.4, they will tell you to approximate something. And again, that's when we know that we need to, our material is a 6.4 material, okay? So again, on the test, you know, when you do your homework, if you in 6.4, you know you're in 6.4, you know what to do. But if you do your quizzes or you do your homework and the question just appear, how do we determine if it's in 6.4? Again, this is the keyword that you want to see, that they tell you to approximate the probability, okay? So in order to approximate this probability, there are a few things that we need to do. Or to find a probability in chapter 6 is there are two things we need, like, as I mentioned, we need the mean and we need the standard deviation. And this is the difference between chapter 6 or section 6.4 versus 6.1 and 6.2 is 6.4, they don't give you the mean and they don't give you the standard deviation. All they do is they tell you, okay, I have this sample, and within this thing here, within the population, we have in a sense of the percentage of people agree or the percent of people disagree, or in terms of those, right? So looking at this thing here, once we have that, once you identify that, remember we need to find our mean and we need to find our standard deviation. So with this problem, to find the mean, this is what you need to do, is we need to take the n times the p, which is again the n times the p, that will be your mean. And to find the standard deviation, we need to take the n times the p times the 1 minus p, which is again, take a square root of that, right? Which is again, this is what we have in terms of standard deviation. So once you identify that, or once you calculate that, and reminder to calculate the mean, or to using the mean or the standard deviation, make sure to use as many decimal as you can, right? So looking at this thing here, this is what we have. Now, what do we need to do after this? Which is again, reminder, after this, we need to find our adjusted endpoint, right? We need to correct our endpoint to estimate this thing, which is again, this is what I asked you guys to do, which is again, sketch your item, right? Sketch your endpoint, ask yourself, which way do I shade it, right? So looking at this thing here, they ask you find or approximate the probability that more than 40. What does it more than 40? Well, more than 40, do you agree that more than 40 meaning the number or the item on your right hand side, right? Anything on the right is more than 40, which is again, they ask you the same item, which is find the probability of X is greater than 40. More than 40, which is again, in this case, this is what I told you guys last time, is again, just sketch your bell-shaped curve, sketch your normal distribution, right? And then all you need to do is once you sketch them, again, identify what is your endpoint, which is in this case, your endpoint is 40. And like I mentioned, do I shade the area to the left or do I shade the area to the right? Which is in this case, anything to the right of 40, anything to the right of 40 will be greater than, bigger than, more than 40, right? So once you identify that, now you need to ask yourself, do I include this endpoint? Do I include this 40, which is in this case Do you agree that there is no equal sign? It's just say more than 40. There's no equal sign, which is we don't include the 40. And if we don't include the 40, which is now, I need to move a little bit bigger or smaller, make this thing smaller by moving to the right. And if you remember yesterday, I told you that your goal or the only thing we're doing is you either add 0.5 or subtract 0.5. And if you remember, if we move to the right, we need to add 0.5. Just remember that you take the step to the right is positive, which is you add. If you take a step to the left, it's negative, then you subtract. You make it smaller by going to the left, by subtract them, which is in this case, this is what we have, which is again, this is my endpoint. My endpoint is 40.5. So once you have the endpoint, now everything else, which is you just go in and you ask yourself, what is my endpoint, which is again, because I shaded to the right, my smallest endpoint will be 40.5, and my biggest endpoint will be some humongous number, which is in this case 10 million. The mean is 37.5, which is this is the mean, and the standard deviation is 5.303300859, which is I plug into this thing here, which is the probability that I have 150 babies and and more than 40 of them weight more than 20 pounds, which is out of that 150, more than 40 of them weight more than 20 pounds, which is again 0.2858. Okay. And similarly, if you look at this thing here, which is one thing is the difference between B versus A is they tell you that 35 or fewer. So 35 or fewer, meaning again, it has to be equal to the 35 or less, right? So looking at this thing here, basically they ask you to find the probability of the number, whatever this X number is, that number has to be 35 or less, or 35 or smaller, right? Or below 35, right? 35 or below. So looking at this thing here, which is again, X has to be less than 35, which is given that, which is again, you sketch your bell-shaped curve, and this is your 35 mark. And like I mentioned, it doesn't have to be precise. It's just need to give you an idea of where is the endpoint and what area. Is it to the left of that endpoint am I looking for, or is it to the right of that endpoint I'm looking for? And again, as you can see, my bell shape is not really much precise, because again, up here is 40, down here is the same line, but it's 35. So again, it's not realistically, but it's just give you an idea. So now once you have that, which is now, do we include 35? Do we include this endpoint, which is in this case, do you agree that X is less than or equal to, which is equal to, we include the 35. And again, to include the 35, we have to go to the right. We have to make this thing bigger, which is because I stated to the left, I make it bigger by going to the right, which is again, if I go to the right, just like before, if I go to the right, I add 0.5. And now if I add 0.5, this is my endpoint, which is my endpoint is 35.5. But looking at this thing here, because I shaded to the left, do you agree that my smallest endpoint will be negative some humongous number up to 35.5? And then my mean will be 37.5, and my standard deviation is 5.303300859, right? So again, this is the difference between the two endpoints. Because I shaded to the right on top on A, I have the right endpoint as a big number. Because I shaded to the left on B, my smaller left endpoint will be a negative big number, right? And again, looking at this thing here, this is what we have, which is 0.3530 or 35.3%. So looking at this thing here, question with A or B in terms of question of how to identify the endpoint or how to adjust your endpoint. And after you adjust your endpoint, how to use your calculator to calculate this item here. Any question? And again, if you don't have question, let's take a look at C, which is C is not really much. They don't have any sugar code between, right? This is what they ask you is approximate the probability that a number who weigh more than 20 pounds, right? The number of baby who weigh more than 20 pounds is between 30 babies and 40 babies, right? So looking at this thing here, they ask you in between, which is again, in between we have this, which is now the other question is, do we include the 30 or do we exclude them? Which is again, because they say exclusive, meaning we exclude the endpoint. So if we exclude the endpoint, which is again, given this thing here, if you sketch this item, which is again, this is 30, this is 40, and we just find the error in between, which is right in the center, right? So now looking at this item here, you need to, because they tell you to approximate, you cannot use the 30, you cannot use the 40 as your endpoint. You have to adjust, you have to correct the continuity, which is again, adjust your endpoint. So how do we adjust this endpoint, which is again, do we include the 30? Which is hopefully you say we do not include the 30, so I have to go inward to make this area smaller to pretty much exclude the 30, which is if I go to the right from 30, I need to add 0.5, and on the 40, I need to go to the left, and to go to the left, I need to subtract 0.5, which is, as you can see, this is my two endpoint. My two endpoint is at at 30.5 and 39.5, okay? My smaller endpoint is 30.5 and my bigger endpoint is 39.5. So once I identify that, which is now, all you need to do is find the two endpoint and plug into your normal CDF, which is normal CDF, a smaller endpoint, which is 30.5, and a bigger endpoint, which is 39.5. The mean is 37.5, and the standard deviation is 5.303, right? So looking at this item here, ladies and gentlemen, looking at this item here, question in terms of this problem here, any question with A, B, or C?
Will it all be normal CDF, or
yeah.
Are there any inverse?
Unless they ask you for the actual number, then you will have to do the inverse norm. But this one here, they ask you to approximate the probability. I don't think they ask you for inverse norm here, but they can. They can say, no, I don't think they ask you. From the top of my head, I cannot think of the question where they can word this so that they can ask you the inverse norm. But for, I don't think so. See if you do the homework. See if they ask you the actual amount. For instance, let's for instance, if I don't think they will ask you for inverse norm. Unless they change it and they want like a top 5% of the group, then something in that nature, then you have to do the inverse norm. But looking at this thing here, I doubted that they will ask you inverse norm or find the actual value or find the actual number of people. But most of this thing here, or the question I took this is from the books. I look at the book exercise, and I don't think I saw any question that applied the inverse norm for 6.4. So that's why I did not take any of the question out that have the inverse norm. But again, looking at this thing here, you can see A, B, and C is very redundant in terms of it's very similar to the previous one, which is again, approximate the probability. And when you are asking to find the probability, that is when you have to do the normal CDF. So for this 3 item, A, B, and C, we still apply the normal CDF, which is we find the probability. Okay. So let's take a look at this item here. This is a new problem. Again, like I said, the previous problem we did, I believe, yesterday, we finished it. So let's take a look at this thing here and see. The only thing different is part C. But before we get there, let's take a look at this thing here. See how would you go and analyze and try to extract out the information that they give you. Because like I mentioned, this class, 80% of the item is try to gather your information, extract out the information they give you, right? The calculation is only 20%, which is a lot of number crunching, right? So again, stretch at work. In a poll conducted by a general social survey, 81% of the respondents say that their job were sometime or always stressful. 200 workers are chosen at random. Approximate the probability of 160 or fewer find their job is stressful, right? So again, look at this thing here. Oh man, that's bad, huh? 80% of people respond to this survey, meaning, for instance, 100 people, 81 of them say that they are stressful at work. Only 19 are happy at their working place. But again, look at this thing here. What are my information here? Looking at this thing here, do you agree that my total worker will be 200? That is how many worker I need to extract out, or those are the random sampler that I need to take. And then the probability that this 200 say that they are stressful is 0.81, which is 81%, right? The probability that each one of them say that they, based on the survey, is stressful at work is 81% or 0.81. So looking at this item here, we know that we need to have the mean and we need to have the standard deviation in order for us to find the normal CDF or even the inverse norm. Without the mean, without the standard deviation, we cannot calculate the area under the curve or the probability. So looking at this thing here, how do I find the mean? Which is, to find the mean, we need to take the n times the p, which is the 200 times the 0.81. And then to find the standard deviation, we need to take a square root of the n times the p times the 1 minus p, which is the 200 times the 0.81 times the 0.19, which is the 1 minus 0.81 is 19.19, which is, if you multiply that, you have a square root of 30.78. Square root 30.78 is 5.547972603. And again, like I mentioned, please, ladies and gentlemen, please use as many decimal as you can, because if you estimate here, if you round up here, unless cost Connect Math asks you to find the standard deviation and round to 2 decimal places, then you tell them 5.55, right? But if you're using the standard deviation to find your probability, please use at least 6 decimal places, right? 6 or 7 decimal places if you can, okay? Or I should say you need to. And look at this thing here. What is the difference with this A, which is A, they actually approximate the probability that 160 or fewer, which is, do you agree that 160 fewer, meaning X is less than or equal to 160, right? So X is less than or equal to 160, which is, in this case, if you look at this thing here, I ask you guys to sketch them out. You don't need to if you can see that you need to adjust your endpoint and do every other thing. But again, I just want you to have an idea of what area, what side, or what region that we try to find the area of, or the probability of, which is anything on the left of 160 is less than 160. Again, this thing give me 2 ideas. Is give me the endpoint. I have to start with some smaller endpoint, and then 160 will be my bigger endpoint, but not quite, right? Remember, because we use the normal approximate the binomial, we have to adjust the endpoint, which is, in this case, do I include the 160? Which is yes, I include the 160, And in order to include the 160, I have to make this thing bigger. And to make it bigger, I have to go to the right. And again, if I go to the right, I need to add 0.5, which is, as you can see, I need to, or you guys need to adjust the endpoint so that you can approximate this item. And to adjust this thing here, you either add 0.5 or subtract 0.5. There's nothing else to it, which is if you headed to the right, you add 0.5. If you headed to the left, you subtract 0.5. So looking at this thing here, this is my endpoint. My endpoint is 160.5, which is, again, I know I start with some small negative number, and then I end up with 160.5. And then my mean, which is, my mean is 162. My standard deviation is 5.54797263. So looking at this thing here, this is what I need to do, which is normal CDF, small endpoint, 160.5. And again, this thing will give me 0.3934. So roughly 40%, right? This thing here is roughly 40%, meaning the probability of 100 of them, 160 out of the 200, right? Say that they are stressful in this item or at the workplace is roughly 40%. Okay. And again, same thing go, approximate the probability of more than 150. So what does it mean more than 150? Meaning the item that we're looking for, the X that we're looking for, have to be bigger than 150. And again, if it's bigger than 150 or more than 150, which is, again, looking at this thing here, I know that I need to sketch this 150, and because it's bigger than 150, I have to shade it to the right, which is, given this thing here, now you have to ask yourself, do you include the endpoint of 150, which is, in this case, we do not, right? Because we don't include the 150, we have to go to the right. And again, to go to the right, I need to add 0.5, which this will give me my endpoint at 150.5. Once you see that endpoint, now you ask yourself, is this the left endpoint or the right endpoint in my normal CDF? Which is, in this case, again, if you shade it to the right, that will be the left endpoint, and the right endpoint will be some humongous number, right? So again, the endpoint will be 150 plus 0.5, which is, I told you, that is your left endpoint, and the right endpoint will be 1 million or 10 million. And again, the mean is 162, and the standard deviation is 5.54, and every other decimal, which is, again, hopefully you guys see that this thing here is very, very redundant, right? Is the wording, they can change it a little bit, right? Meaning in A, they can just say fewer than, or in B, they can say 150 or more, right? They can change that up. But the idea or the concept is the same, which is find the mean, find the standard deviation, adjust your endpoint, and put in your normal CDF to find the probability or to find the area under the curve. Question with A or question with B here. Now, C, right? Approximate, which is, again, hopefully you guys see that C is easy in terms that there's no sugar coating in terms of between, right? Between is basically, okay, I have this 2 number, I'm looking for the item in between that, right? More than, greater than, above, that is the word that you have to shade it to the right. Fewer than, below, or less than, right? Those are the items that you have to shade it to the left. And if it's in between, you just know that you need to shade it in between. But what is the difference between this problem C in number 3 versus problem C in number 2? In this one here, we say that it's inclusive. What does it mean? Inclusive, meaning we include the endpoint. We have to include the 155, and we have to include the 162. So given that, this is what we have, which is, again, we sketch this item here, and we put in our 2 value, 155, between 155 and 162, which is, do you agree that this item here This green item is the item that between 155 and 162, which is, again, I just shaded at that region, which is, those are the region I'm looking for. Now, the next thing, or the most important thing in 6.4 is, after you found the region, after you find your mean, after you find your standard deviation, we have to do one extra step, which is we have to adjust the endpoint. Do we include the 155, which is, do you agree that we need to include the 155? If we include the 155, we cannot go to the right, because if we go to the right, we cross or we throw away 155. So in this case, everybody see that to include the 155, I have to extend it outward. And if I extend it outward, I have to subtract, because I go to the left to make this thing a little bit bigger, which is I subtract 0.5. And again, because I include the 162, I have to go to the right from 162, which is, to go to the right, I need to add them. Okay. So again, everybody see the difference between this problem where I need to subtract on the left and add on the right, compared to the previous problem where I add on the left and subtract on the right, right? Because last time we exclude, we make the item smaller. We include, we have to make it bigger. And to make it bigger, I have to make this item a little bit wider, right? Wider. So once I make it wider, which is I have to go negative. And again, once you do this thing here, your endpoint will be 154.5 and 162.5. Once you have that item, which is, again, my two endpoint, at the 155, I subtract. At the 162, I add, which is, now we know that the left endpoint is 154.5. The right endpoint is 162.5. And the mean is 162, and the standard deviation is 5.54. 7972603. And again, looking at this thing here is 0.4477, right? You know, the only thing that they can ask you in terms of inverse norm is they will ask you between what two value is considered the middle 44 or 45%, which is, again, that's, you know, they kind of, that will be a very stretched out. But look over your homework, and if you encounter that problem, let me know, and I can, well, if you encounter and you know it, then you don't have to let me know. But if you have problem, just let me know. Question with this thing here, question with example 3. Question on how I find the answer, or question on how I find the endpoint, or anything.
How do you find the normal CDF again on the calculator?
You hit second VARS, second var. Is the button next to the clear button? You see your clear button?
Yes.
Next to it on the left, VARS.
Okay.
So you hit second var, and then you go down to number 2. That's your normal CDF. Number 3 is the inverse norm. Were you able to find it?
It says Zoom.
Zoom. Second var is Zoom.
You said right by the clear button, the VAR button.
Yeah, you have to hit second. Hit
Oh,
second
VAR.
first.
Okay,
Yeah.
okay, got it.
Okay. No. Any other question with this thing here? So let's take a look at this problem. Let me ask you guys to do this problem for me. Let me ask you, if you see this problem on your tests, on your homework, or on your quizzes, on your final exam, see if you can do this problem for me. Let me give you this problem, and then I will give you 5 minutes, and then we will go over and